Hello friends, you are watching This is Awesome Videos, and today we are going to learn chapter circle. Okay, in a past video we starting the chapter circle. We see the very basic formulas that we all know from the 10th standard and 11th standard. So today we are going to cover a good number of formulas which is going to be asked in JEE mains and advanced also. So please make a note of this formulas. Okay, so let's get started. The first one is the equation of a circle when the coordinate of the endpoints of the diameter are given. That means if we have any circle here and the endpoints of the diameter, that means this point and this point. If the diameters and points are given, let's say it is x1, y1 and x2, y2. This is x1, y1, this is x2, y2. Then the equation of circle can be directly find out that by the formula x minus x1, x minus x2 plus y minus y1 into y minus y2 is equal to 0. By using this formula, you can find out the equation of circle directly. And if you don't know the formula, and you just know these two coordinates, you can find out the equation of circle. How? You know the coordinates. Now see, the center is the midpoint of this two, so by using the midpoint formula you can find out the center. And if you have the center and the one end point of the circle, then you can find out the radius by the distance formula. And if you know the center, if you know the radius, then you can have the equation of the circle. Okay, but if you want to don't waste the time, then please remember this formula: x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0, the equation of circle. Okay, now what is the next thing? Now see, if we have a straight line and a circle, now see, if we have a circle having origin as a center, then the equation of that circle must be x square plus y square is equal to a square, and the a is the radius. We all know that. Now the equation of line is equals to y is equal to mx plus c. Say this is the line. This is one line. Now what we have, if line does not intersect the circle, if see in this line is not intersecting the circle, then the perpendicular from the point on the line to the circle, like this is the perpendicular from the line on the center of the circle, is greater than the radius of the circle. Okay, if the line does not intersect the perpendicular, okay, if the line does not intersect the circle, then the perpendicular to the line from the center of the circle is greater than the radius of the circle. So that is equals to mod of c upon square root of 1 plus m square greater than or equal to a. C upon square root of 1 plus m square. This is the perpendicular distance from the center point on the line to the center of the circle. This is derived from this which perpendicular distance formula. C upon square root of 1 plus m square is must be greater than what? A is the radius. If it is greater than a, see here, this is the radius, and you can see this is the distance. It's easily from the it is easily understood by the figure that it must be greater than. Okay, so this is the fact that if the line is intersecting the circle or not. So if you want to check that, you have to use this formula: c upon square root of 1 plus m square greater than equals to a. If this equation satisfied, then it is not intersecting, and if it is not satisfied, then it is intersecting. Okay, now this is a very good thing. Now if line intersect the circle, then the length of perpendicular to the line from the center of the circle is less than the radius. This is true. If it intersect, then it is radius, and if the perpendicular distance and the radius is equal, then it touch the radius, it touch the circle like this. If this is a circle and we draw a line like this, then the perpendicular distance to the circle must be equal to the radius. So c upon square root of 1 plus m square is equal to a. 3 points to remember. If it doesn't intersect, then the perpendicular distance is greater than a. If it intersects, then it is less than a. And if it touches, then it is equals to the radius. Okay. Now, the next thing, the next topic is very much important. So please keep focus in this. It is common tangents. This is a very good thing. Common tangents. Now what we have? We have two circles here. See in the figure, we have two circles here. Now, if we have two circles, then the maximum common tangent drawn to these two circles are 4. Maximum number of 4 tangents you can draw. See, this is the first one, this is the second one, third one, and fourth one. 4 tangents can be drawn maximum if we are talking about the two circles only. Now, this two, this one and this one, they are known as direct tangent. They are known as direct tangent. You see, the tangents are drawn directly to them. And these two, which are making cross, these are known as transverse tangent. Okay, these are known as the transverse tangents, and these two are the direct tangents. Now, this case comes in picture if the circles are not intersecting each other, they are separate. They are separate. Okay, when the two circles neither intersects nor touch each other, there are 4 common tangents. They are not touching each other, they are neither intersecting each other. When this case arrives, then and then the 4 number of tangents appears. 4 number of common tangent. Okay, but when they intersect, there are 2 common tangents, and that are directly if they intersect like this and this, they are intersecting externally, then and then 2 common tangents are there. Okay, we are seeing in next slide. So direct common tangents, this you can see, these are the direct common tangents. Direct common tangents to the circle meets on the line of the center and divided externally in the ratio of the radii. Now see, this is also very important thing. This is the common tangent, this is the common tangent. They intersect each other at this point F, and this point comes in the line of center, passing through both the center, and this is the ratio. What is the ratio? Where we have to locate this point. To find the ratio, they are touching, divide the centers externally in the ratio of radius, that is R1 and R2. Now, if we are talking about transverse common tangent, then transverse common tangent also meets on the same line, and also divides in the ratio of radii, but internally. The difference is this point is externally and this divides internally. If the division is internally, then the ratio is greater than 0, and if it is externally, then the ratio is negative, that means less than 0. Okay, just remember this. We are going to solve the problems on that, but today just make a note and remember this, that if we are talking about direct common tangent, they divide the center of line externally in the ratio of radii, and in the transverse common tangent internally in the ratio of radii. Okay, okay. Now, some of the important facts, that one circle lies completely inside the other without touching, there is no common tangent. So like this is one circle and this is the other one, then you cannot make any common tangent. Okay, so this is a fact. Now next, when two circles touch each other internally, one common tangent can be drawn to the circle. Now like this and one circle like this. Now one common tangent can be drawn and it is this one. Okay, this is common tangent. Next point, when two circles intersect in two real and distinct points, two common tangents can be drawn to the circle. Okay, so we have two intersecting circles like this at two different points, then two common tangents can be drawn like this one and this one. Okay, when two circles, next point, when two circles touch each other externally, three common tangents can be drawn. This is also a good thing. Externally touch, like this. Now this is the first common tangent, then this is the second common tangent, and this third one. See, this is the third common tangent. Okay, when two circles neither touch nor intersect and one lies outside the other, then four common tangents can be drawn. See, you have 1, 2, 3, 4 number of common tangents starting from 0, 0, 1, 2, 3, 4. 5 points, 5 type of common tangents, 5 numbers of common tangents, but at each and every different cases. I drawn out 5 cases and to understand you. Okay, so please remember these things. Now we are going to make a table on that. See, 4 common tangents. When 4 common tangent, when the radius, when they do not intersect, do not touch each other externally, like this. In this case, this is the center C1, this is the center C2. Then in this case, the distance between the center, it is easy to visible. The distance between the center, that is C1 C2, is less than, sorry, distance between the center C1 C2 is greater than the radius summation of radius. You can see the distance between this is the radius R1 and this is the R2. The distance between the center is greater than by this distance. Okay, so for common tangents, the condition for that is R1 plus R2 less than C1 C2. Now three common tangents. We see in the past slide that 3 common tangents when they touch externally, like this. So in this case, this is the center, this is the center, then the distance between the center is equals to the summation of radius. So R1 plus R2 is equals to C1 C2. Now 2 common tangents when they intersect each other. So what's the condition? Condition is the difference between R1 minus R2 less than C1 C2 less than R1 plus R2. Okay, modulus of, whenever we are talking about the difference, we have to take modulus. Okay, because sometimes it's inside the circle or intersecting, so we have to take the modulus here. So it is modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. Now 1 common tangent, that means they are touching internally, like this. So in this case, it is also easily visible that the distance between the two center, that is C1 C2, is equals to the difference between them, that is modulus of R1 minus R2 is equals to C1 C2. And no common tangent, that means lie inside another, that means this and this. Okay, and in this case C1 C2, the distance between the center is less than modulus of R1 minus R2. So remember the condition and you will know the number of tangents. Sometimes it is asked how many common tangents can be drawn. To check, you just need to know R1 R2 and C1 C2 and then apply this condition and get the answer. Okay, so this is all the theory portion about this video. Now we are going to solve one numerical of JEE 2013. Now see, I am going to post almost 3 more video on circle covering the theory and past year JEE problem. So keep watching. This is the JEE 2013 question. See, the questions are asked from the very basic things. What they say, the circle is passing through 1 comma minus 2. That is in the 4th quadrant. So in this figure you can see 1 comma minus 2. Here a circle is passing through that point and touching the x-axis at 3 comma 0. Now see, it touches the x-axis at 3 comma 0 and passes through the point which, so they give 1 point which circle is passing. We know that the circle is touching x-axis at 3 comma 0, and what they ask that out of this 4 point the circle is passing from which point also. To find the correct answer, we have to find out the equation of the circle. Now we know that if the circle is touching x-axis, then the center, if we draw the perpendicular here, then the center x coordinate must be same and y coordinate, let's say k, the center becomes 3 comma k. Now when when the circle touching x-axis, then the radius must be equals to k. See, this is the y coordinate, this is k, and this is equals to the radius. See, this is the y coordinate and this is equals to the radius. So we know the basic equation: x minus h whole square plus y minus k whole square is equal to r square. H is the x coordinate of the center, that is 3 here, y coordinate is k, radius is also equals to k. Now what they say it is the passing from the 1 comma minus 2. So just put 1 comma minus 2 in the x and y. Okay, and if I put 1 comma minus 2 here, I have here 4, here I have k plus 2 and is equals to k square. Here it is minus 2, 1 comma minus 2. Okay, so k plus 2 square is equal to k square. Now just expand this: 4 plus k square plus 4k plus 4 is equal to k square. Now k square and k square gets cancelled out, so we have 4k is equal to minus 8, so k is equal to minus 2. So the circle, the equation of the circle, just put k is equal to minus 2 in this equation, the assumed equation: x minus 3 whole square plus y minus k, k is minus 2, so x minus 3 whole square plus y plus 2 whole square is equal to k square, that is 4. Now just use try and error method. First put this equation, then this point, then this point, then this point to the given equation. The point which satisfies this equation is our answer, and the right answer is 5 minus 2. If we put 5 here and minus 2 here, we will get 4 in the right hand side. So 5 comma minus 2 is my right option, that is option number 3. So this is all about today's video. I am going to post more formulas, more theory portion of the circle. So keep watching. Thank you for watching this video. If you like this video, don't forget to share it and hit that subscribe button. Thank you.